Hey guys, welcome back to part two of the movement series. Um, okay. So what we're gonna do today is make the sliding system. Yeah, I know. So we did dashing and sprinting last time. This time we're going to make the sliding system, and hopefully we will make the um climbing system as well. Hope this video isn't over 3 hours, and let's get to it. So let's create a wedge just to test our sliding, and let's just make it like just like so. Yeah, I think so. So is good. And then let's just like anchor it and whatever. And what we're gonna do is we're gonna go back into our script. We're gonna create a new input event. We're gonna say if input.keycode is equal to enum.keycode, oh no, sorry, movement config dot slide key, then let's have a slide cooldown. Actually, no, we don't need it. We're just gonna say if self dot crouching or self dot dashing or self dot climb or self dot ledge holding, then return end. Then we're gonna say if humanoid dot move direction dot magnitude is equal to 0, else. So this means we're going to slide. This means we're going to crouch. Okay, so we're gonna say if self.sliding, then return end. Self.sliding equals to true. And let's go self slide. Pretty self-explanatory. And then if we're gonna go to our input ended, we're gonna say if input.keycode is equal to movement config dot slide key, if movement if self.sliding is equal to false, self colon slide. So let's try this. We're gonna go in here. We're gonna go if self.sliding else. So we're gonna do if we're just gonna do local body mover equal to self.root part find first child slide velocity. If body mover task dot we're actually just gonna go debris. Let's just destroy it actually. And then if not, we're also just gonna make sure there's no body movers just for safety. So this part's gonna be all for safety. Alright. So right here we're just gonna say check if velocity exists. If it does, arrow there, then we're going to destroy the velocity. And let's just quickly do self.slide track. Stop slide track. Safety. And whenever I mean safety, I mean just in case they get hit while sliding and it just like cancels it out or whatever, you know? We'll probably have something to deal with that, but yeah. And then we're actually going to play it. Play time of 0.1, 10 and 1, and we're gonna start the slides track. We're gonna create a body mover. I'm gonna set it to body velocity, and we're gonna say body mover dot velocity. Oh yeah, it's a body mover. Velocity self dot root part dot cframe dot look vector times 10 plus self dot root part dot cframe dot up vector times -10. And we're gonna set the max force to like one. I'm gonna set it to like 1000 to the power of 2, but that's a really big number. Let's do 1000 times 1100. So that's 3, another 3, 2. That'll be like 1 million. I think so. And then we'll just set the parent to self dot root part. And let's give it a name of slide velocity. So if I hit play now, see. Alright, let's try this out. Temp index nil with find first child. Okay. What do you mean attempt to index now? Refer to remove it as a body mover. Let's try it now. Okay, let's see what we get. Of table. Oh, I did self, not self dot root part. Okay. 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 Let's try this out now. Okay, let's try this out now. Yep. I mean, it does the job. It's just a little wonky. What if we go down here? I mean, it slides. Let's try and do a little something. We're gonna go back up here. We're going to make a new, no, we're gonna go back to our render steps. We're gonna say if self.root part find first child slide velocity. We're gonna say self.root part dot slide velocity dot velocity equals self.root part dot cframe dot look vector times 10 plus self.root part dot cframe dot up vector times -10. So this constantly, no matter which direction you move, it'll constantly update your velocity. And more, let's give it less max force. Let's make the max force like 10,000. Uh, let's see. Did I do self find first child? I think I did that again. Okay, let's. No, it's nothing crazy. What do you mean? Attempt to index no. If self dot row part. Yeah, that's nothing crazy. If self dot row part. Let's just put it in a little safety nested statement. Just like so. Okay, let's try this. Where is this? Self dot root part. Why is self equal no? What do you mean? Self dot root part, yes. Is the root part like? Okay, wait. I'm just gonna do wait for child humanoid root part. Stop causing us a lot of issues. Okay, then let's try it up here. It should be that you go down faster if you're going down a slope. Let's get something called. Let's make this called self dot slide charge. Self dot last pause. Self dot root part dot position, and we're gonna constantly update it inside of our render step statement. So self dot last pause equals self dot root part dot position. I'm gonna say if self dot. I say if self dot report dot position dot y is let's then self dot last position dot y then self dot chart to self dot report dot position dot y. But that I'm gonna snow bunny here. Okay, let's try this out. It should. Try it now. What do you mean? Oh, my bad, my bad. Alright, let's try this out now. Whoa. Yeah. Yo, we just made flying. Oh, we broke Roblox physics. Alright, let's just do wrap it with a math.abs. Oh, that's why. And just in case, make sure it's not a negative. Put that. Oh, that's. Hmm. Okay, that should work. Let's try it out now. Hmm. Um, try this system out now. Okay, let's fix this up a little bit. Let's just make, what to do, slide power. Make it 15. Or, um, what's the slide charge? Just like so. Try this out. I gotta check how we go down and up. Give me a second. Okay, so we're gonna use dot product. All right. So if we're gonna go back up here, um, what we're actually gonna do is we're gonna say if self dot, I'm gonna say local dot product plus self dot humanoid dot move direction. Okay, no, it's self dot root part dot cframe to our vector to object space self dot humanoid dot move direction dot shift to z. Let's print dot product, and I think product plus 0, then print straight. Else if dot product is 0, print down. Let's check. So since we're going down, let's say greater than 0. Okay, I figured it out. We're using Y. We're using Z, not Y. So uh, this would be up, down, straight. Let's do that. Let's do that. Okay, let's see. Let's just print dot product. And let's constantly print it out. Like so. Just constantly at 0. That's really interesting, you know? What if we print self dot humanoid dot move direction dot y? Well, guys, I will be right back. Alright, so what we're gonna do is instead of doing this, we're literally just gonna do if self dot last pause is equal to dot y is equal to self dot y position dot y, then slide or self dot slide charge equal to L dot y is greater than or dot position dot y, then self dot slide charge is going to be equal to 10.5. Try this 2.5, 0.25. Try this out now. You can see you go really slow up this slope, and boom, you slide right. Okay, that's really good. Exactly what we wanted. So, and then you go back to being slow. Really slow, and then you slide down. Really nice, exactly what we wanted. Let's just make it a bit smoother by making this 0.25, and yeah. So that's pretty much sliding. And let me quickly go over it. So first off, we make sure that if player click slide key, and then if not player is climbing, holding onto ledge, or dashing. So this is if player crouches, then crouch code. This means that player is moving, has intent to slide. Player is idle, has intent to crouch. Alright. So if player is sliding, we don't do anything. We set sliding to true. Then we call sliding function, or I guess you call it a method. Right? And then if player releases slide key, we're going to make sure they are sliding. We're going to set sliding to false and call slide function / method. So this is if player not moving up or down, make them go at 25% speed. 15. If player is moving up, increase speed of 15 by 10 times. If player is going down, so if y is less than this position, we're going to reduce speed to 25%. And then if we find the slide velocity, we will constantly update it. And then reset the last position variable. Pretty easy. And then inside of our slide method, so if the player is sliding, we're just going to make sure we remove the sliding velocity if it exists for whatever reason. Alright. And we're going to create the slide velocity. Alright. It's actually going to be 10K. Name it. And parent it to root part. Check if it exists, then we destroy it and we stop the track. Pretty easy in my opinion. Yeah. So that's pretty much sliding for you. Let's quickly go to some tests on it. Okay, let's try it out. So let's quickly sprint up to the top. And if we slide, and we go really slow. Pretty simple. Alright, and we can dash. Pretty easy. And yeah, so we got sliding implemented. Make sure we can't let's just set the walk speed to 0 so they can't yeah, let's do that. Let's just make it so that they can't boost slide. So 0. Let's just make it so they can't. Pretty easy. Do the same thing here. We're just gonna reset it. So reset walk speed. Reset jump power. Pretty easy stuff. Nothing too crazy. I know it's stuttering. Might be because of a mass. Whoa, might get better in the future. Yeah, pretty easy. And then now let's do crouching actually, because why not? So let's go up here. So we're gonna go back here. Get rid of this. We're gonna say if self dot sliding or self dot okay, crouching, not self dot crouching. We're gonna do self crouch. Pretty easy. And it's gonna reverse crouching value. Really easy. And then with our crouch code, let's say if self dot crouching else. So if player crouching, if player not crouching. So if they are crouching, we're gonna do self dot humanoid dot walk speed equal like 8, and self dot humanoid dot jump power equal 0. Maybe like 12. I think that's good. And then if self dot humanoid dot move direction dot magnitude equals 0, else. Well, he has to be standing up, so self dot crouch idle track play 0.1. And then if not, we'll set the walk speed back to 16 and the jump power back to 50. And then self dot crouch idle track, we're gonna stop it. We're gonna do the same thing with the walk track. Stop it. So, reset walk speed, reset jump power, boost walking, reduce jump, play idle track, stop idle track, and stop walk track. And we're gonna go back up here to our move direction. We're gonna say if self.crouching. So this is when they go from running to idle. So if player crouching, we're gonna say self dot crouch walk track stop self dot crouch idle track play 0.110. Do the same thing here. If self dot crouching, then so if player crouching, we're gonna stop the idle track. And we're gonna play, or we're gonna do the walk track. Pretty simple. Try this out. So you see all the sounds in our root. Let's disable all the sounds in our let's just disable all of them. So we're just gonna say let's create an array called previous sound properties. So previous sound properties. We're gonna say if after crouch, we're gonna go in here. We're gonna go for underscore sound in pairs self dot get children. If sound is a sound, table dot insert self dot previous sound properties sound dot. Oh yeah, let's just do sound previous sound properties. And then sound out volume was 0. And if self dot previous sound. Okay, let's try this now. Let's go like so you can see no sounds being made at all. I'm gonna go up here and then start crouching. Oh, we shouldn't be able to do that. Whatever. Yeah, let's just fix that real quick. dash code or self dot crouching. Very nice, very nice. So let's hit play now. So flight control. No sound being made at all. Very nice, very nice. I'll go back to normal. You can see if we go into our humanoid root part, the one has 0 volume, and the moment we hit this, boom, flawless. That's absolutely flawless. So yeah. And you guys are probably wondering when we're going to add sounds and VFX to our movement system. We're going to be doing that in the last lesson. Alright, so maybe in part 4 or part 5 of the movement series. But yeah. Okay, thank you so much for watching. That's pretty much it for today's video. And yeah, see you in the next one.